Okay, so they have no interior points, so I'm going to redraw my A, all three of my rays. All right, so it's O, A, B, and C. Okay, so remember how we talked about, we just looked at a single, actually, let me just do like a single angle, and I'll label it differently, like D, E, and I'll just say, I don't know, this is like T. There you go. It's a different angle. But there's three different, an angle splits the plane into three separate areas. So we have the exterior, which is out here. So this is exterior. So if I have a point out here, like F would be an exterior point from this angle. Okay, and then I also have the interior. So this is like angle, let's say that's point H. H would be interior because it's inside the angle. And then you have literally the points that are on the rays that make up the angle. So if I label this one, let me use as G. Those are the three locations. So if I ask for a point interior, inside, right, interior is inside. If I'm looking for an interior point, it would be literally, you look at the angle and it's whatever's inside the angle. So if I'm looking at these adjacent angles share a common vertex, cool, that's point O. They have a common side, that was ray OB, but they have no common interior points. So let me just erase all this nonsense. This is a lot of stuff. Okay, so they have no interior points, no common interior points. All of the interior points of AB would be in this blue shade region. All of the interior points of BOC is in that pink. They don't overlap at all. Okay, that's adjacent angles. Like really in-depth explained it. Now it's up to you to make sure you review the vocab. All right, a linear pair. So a pair of adjacent angles whose non-common side are opposite rays. Okay, so let's break it down. Adjacent angles, we just went over. So adjacent angles have one common ray. So I have AOB right here. So I have AOB. Let's see. So this is angle AOB. Can you read that? No, cannot. So here's angle AOB. And then I have angle BOC. So this is angle BOC. These are adjacent because they have a common ray. OB is the common ray right here. We have no common interior points, right? So they literally are totally separate. They don't overlap at all. Okay, so we just proved they're adjacent angles, but now let's talk about how they're linear. So they have the non-common sides are opposite rays. So the common side was the ray OB. That's the common side. The two non-common sides are opposite rays. So remember, if you have two opposite rays, it forms a line. So this guy right here is a non-common side because the other angle doesn't use the ray OA. OC, this is the other opposite ray, and then together they form a straight line. So you have this guy right here. Oh, you can't even see that. Right, this guy's non-common, this guy's non-common. They form a straight angle. They form a 180-degree angle. They're flat, they're a line. So linear pair, the cool thing is if I would add these two angles together, if I add AOB and BOC, you add them together, they would equal 180. Right, so linear pairs add to 180. Yep. So a lot of times you might see this as, let's see, do something like this. I'm trying to make it so that way these overlap more. Okay, so I was just trying to draw two lines. So just a second. So let's see, 1, 2, 3, 4. So 3 and 4, angle 3 and angle 4 are a linear pair.
Yep, that's my question.
Angle 1 and angle 4 are a linear pair. Because did you see the way I constructed this? I put a ray going this way, and then I put a ray going that way, and together they formed a line. So together these two form a linear pair because they are straight line. Together these two form a straight line, a linear pair. 2 and 3, as well, 1 and 2 as well. We're going to go further in depth and talk about why that is, but the linear pair, what does it mean? It's literally, they have to be adjacent, so they have to be touching, and the non-common sides, aka the one that they don't have in common, the one that's not touching, have to form a straight line. Vertical angles. So I started doing vertical angles in the previous problem. So vertical angles are two non-adjacent angles formed by two intersecting lines. Okay, so let me label these and then we'll talk about which ones would be vertical angles. 1, 2, this is angle 3, angle 4. So when I say angle 1, I'm talking about this angle right here that's formed out by J and M. So when I say angle J and M, that's the same thing as saying angle 1. So I'm just labeling them with numbers now because it's a mouthful to have 3 letters. Okay, so I want to know which ones are vertical angles. So they're non-adjacent angles, vertical angles, it's literally the one right across. So the angle 1 and angle 3 are vertical angles because they're directly across from each other. They're non-adjacent angles formed by two intersecting lines. So you have two intersecting lines. Literally, when I look at the first angle, it is adjacent to 4, it is adjacent to 2, and whenever you have two intersecting lines, you'll only ever have 4 angles. So it's literally the only angle that it's not adjacent to. So that's why it's 3. And if I would want to talk about angle 4, what one is vertical with that guy? Angle 2, because 4 is adjacent to 1. 4 is adjacent to 3.
Which
So
makes them congruent.
the 4 and 2?
Right?
Exactly.
Yeah.
Is this where I'm going? Yes, it is. Haha. Do you have questions so far? All right. I think this pacing is a little better than yesterday. Cool. Perfect. All right. Appreciate the feedback. All right. Angle pair relationships. Okay. So vertical angles are congruent. That's what he was just talking about. The vertical angles will be the same measure. Complementary. When you have complementary angles, it's two adjacent angles. It's a very specific case. Two adjacent angles. So that means they have a common, and they have one common ray in between them. When you add the two angles and they add to 90, they're complementary. So like, yeah, if you comment on someone, give them a compliment, you know, they'll probably feel real special. Maybe they're a real hot shot. 90 degrees is really hot temperature. I don't know. You gotta think of a way to remember it. Versus supplementary. Imagine if you take like steroids, you'll be real bulky, right? You take supplements, you'll be real bulky. It's real big. Supplementary is 180. It's larger than 90. Okay, so the way I remember supplementary and complementary, supplementary is when you like bulk up. 180 is larger than 90. Supplement goes with 180. Complement goes with 90. You have to come up with a way to remember it because sometimes my antics don't work for other people. Okay, so supplementary, they add to 180. So over here you see if I would have 120 and 60 and I put them together, they would be supplementary. Supplementary are angles with measures that have a sum of 180, complementary is sum to 90. Notice that I could say two angles are supplementary and they don't have to be adjacent. Crazy. All right. The angles in a linear pair are supplementary, so I already talked about that, how they add to 180 degrees. So if two angles add to 180, we say they are supplementary. I can say two angles are supplementary, and they don't have to be next to each other. It's not a condition. But to be a linear pair, you have to be next to each other. So it gets like, man, it's a vocab. I'm being serious. The vocab gets you. All right, so let's go ahead and let's solve for x. Does someone want to explain how to do this one? Let's have volunteer. Eeny, meeny, miny. All right, Ashton. So first, how do these two angles compare?
They're the same.
They're the same because they are?
They are supplementary.
Vertical
Am I
angles.
getting it right?
They're vertical angles. They're vertical angles.
Right.
Yep.
Vertical.
So which means vertical angles are congruent. Congruent means the same, equivalent, equal. So 2x, so you set them equal. 2x plus 10.
10 equals 5x minus 5.
Yep.
And then just solve that.
And then we go through and solve.
And then
So when I say, I don't want to like lose you when I say go through and solve. That's real mean of me.
I can solve.
So, I'll subtract 2x. Why do you think I'm subtracting 2x to move it to the other side?
Because it makes it easier.
Yeah, it makes it be a positive 3x. Because I don't like dividing by negative numbers. That sucks. Okay, now I need to add 5 on both sides, right? So I'm trying to move everything with an x to the right side, everything with only a number to left. And I always tend to try to have the coefficient, the number in front of my variable, I try to have that be positive. I don't know. It's just, I don't know, I do it. And lastly, I divide by 3 to get x by itself, so I find x equals 5. Okay, yes, question?
And then you take
That's
that, plug it back in.
No,
find
that's
one
it.
Side, add that
It just, what was the question? It was asking to?
Solve for x.
So.
Oh.
RTFQ. If you're doing SAT prep, they tell you that's a strategy. Read the full question. Read the full question. What am I asking for? Am I asking for X, or am I asking for you to plug it back in? Tricky. Just double check. You're doing what you're supposed to. Don't do more work than you have to. You could plug it in. That'd be rad. We could find out what the angle would be, but why? We don't have to. That's gonna a little extra. All right, but I mean, you're gonna head, but I like it. I like it. Okay, so B. Let's go over here. Noah. Yeah. See, I got your names. One day, golden. All right. So what's the special part about this? What's like the thing you should notice right away?
It's complementary.
Exactly.
Nice.
What does complementary mean?
They equal 90 degrees.
Beautiful. Air 5. That's wonderful. Right? So we use the right vocab. So they're complementary. These two angles, they are adjacent because they have a common ray between them. They add to 90. Okay, cool. Keep going.
So dx minus 2 plus x squared equals 90.
Exactly. So the first thing I want to do is combine like terms, and then I'll go ahead and I will solve for what x is equal to. So it's not like a pet peeve. I guess it's just a helpful hint. Like I put parentheses around, because imagine if instead of +4, this was a -4. I don't know. I just try not to lose negatives. But since it's just adding, I can just combine like terms. 3x plus x is 4x. -2 plus 4 is +2. I'll move this up a little bit. Okay, so if I subtract 2 on both sides, because I'm trying to get x by itself, so we're following the order of operations. So right here, 100%, I'm expecting you guys to be like down diggity groovy with this. You got to be understanding algebra 1. All right, so this is what, two-step equation? Subtract 2, then divide by 4. Like I gotta have you guys here understanding how to do that. Okay. That way I don't have to worry about the algebra with you. I just have to make sure we understand the definitions of everything we're going over in geometry. Okay, so we divide by 4 everywhere, and we find that x is 22. I go back, I say, what is this question asking for? Oh yeah, solve for x, we did it, cool. We don't have to plug in, that's too much work. It's not asking us to.
You want to find the other side?
All right, so let's keep going.
You only have to use the degrees of the angle if it's complementary.
Or if it's like supplementary, because then I know what it should add up to. So if it's vertical, I know they're going to be equal. If it's complementary, I know they'll equal 90. Supplementary, they equal 180. All right, let's keep going. So we're doing well. We're doing great. Let's go to Jacob. Yeah. Example 2, I'll read it for you. Find the measure of two complementary angles if the difference in the measures of the two angles is 12. Ooh, this is a tricky one. You can tap out. Do you want to do the next one?
Complementary.
Okay. Because this one's a little tricky trick.
Oh, haha, it's a supplement. Oh, no,
So, okay, first, complementary. What does this mean?
They
add to?
Add to 90.
90 degrees. Okay. So I have two angles, and they measure to 90. Okay. The difference in the measures of the two angles is 12. So what that means is, let's see. Let's let x equal the angle. And I know that, I'll say angle 1. And I know that the second angle, right, angle 2, is going to be 90 minus x, because together they have to add to 90. So if I take 90 and subtract my first angle, I'll see what my second angle is. Okay, so I have angle 1. I'm letting it just be x, whatever number that is. And if I do 90 minus that angle, it'll be whatever the other angle will be. So we're groovy with that so far. So I'll say this is angle x, and if this is totally 90, this angle right here would just be 90 minus x, because together they have to add to 90. Okay, so the difference means subtract. The difference in the measures of the two angles is 12. So if I do x minus, so my first angle minus my second angle, it's going to be 12. The difference when I subtract them will be 12. So I had angle 1 minus angle 2 is 12. And a big reason why I put parentheses is, guess what? If I have to distribute this negative, that changes things. So x minus 90 plus x equals 12. This was the trick play. Knowing how to set up this problem, how do these angles compare to each other? Translating the English to math. So add 90 on both sides. So 2x equals 102. Divide by 2, I see x is 51.
And the other one's 39.
So let's see. So x is 51, and we want the measures. Find the measures. So I have to find both angles.
39.
Oh my god, guess what? I found x is 51, and x is literally my first angle, so I already have one of them. So now if I do 90 minus 51, that will be 39, and that's my second angle. So those are my two angles. So this is a step up, but you got it. Yeah. All right, the measure of a supplement of an angle is 60 less than 3 times the measure of the complement angle. What is the measure of the angle? Oh my god, this is too hard. I can't do it. Ugh, this is crazy. Just joking, we can do it. All right, you just have to break it down. Literally break it down. Supplement, we know what this means. It means 180 degrees. So it also says, let's see, supplement of an angle is 60 less than 3 times the measure of the complement of the angle. Okay, so I'm going to let my angle 1 equal x. How would I find angle 2?
Angle 2 60 minus 3x.
So 60 less is subtracting 60. So let's see. Angle 2, the measure of supplement of an angle is 60 less than 3 times the measure of the complement of the angle. Ooh. Yep, 3 times the measure of the complement of the angle. So 60 less.
90 degrees.
So 60 less, so 3 times the complement of the angle. Hello.
So 3 less than an angle that plus the other angle would equal 90. So we're talking about 1, 2,
Okay.
3.
So the complement is, so 90 minus x would be of the complement. And I want 3 times that complement, and then I want 60 less. Ugh, what the heck?
Is this what it looks like?
I can't see your paper. I need new glasses. I told you that.
Oh, it is really,
Okay, so this one's hard. This is probably harder than something I'll give you. I just wanted a little challenge.
yeah.
Are you okay? All right, so the measure of the supplement of an angle is 60 less than 3 times the measure of the complement. Okay, so complement adds to 90. So if I do 90 minus x, that's the complement. 3 times the complement. And then I want 60 less. So I know together, x plus this whole shenanigans is going to equal 180. Yeah. 3 times 9 is 27, so 3 times 90 is 270. minus 3x minus 60 equals 180. Let me pause here. Let me pause here. Do you understand where this came from?
What do you look like?
Huh?
I'm very visual.
Yep. Okay, so let's see. I'll draw it for you. I'm trying to figure out where I can draw it. Maybe over here. So it's gonna look something like this, where this is x, and then I'll say that this is like 180 minus x, or it's the other angle, huh?
Then where does supplement 90?
So, well, because it's being tricky. So it's like, okay, hey, if this,
complement, sorry.
so right, the complementary. So I have this angle x, and then this angle right here would be the supplementary, because that plus my original angle would be 180. So if I go back to my original angle and I say, okay, what would the complement be? And so this, I'm going to put S for supplement. So the supplementary, not only is it going to be 180 minus x, it will also be equal to 60 less than 3 times the complement of the original one. So let's say I have a 90 degree right here, so I could find what the complement would be, multiply it by 3, and then subtract 60. So it's, right, okay. This is not a nice problem. Okay, so x minus 3x, I see why they skipped it this year. Because she like crossed it out, Miss Co didn't do it. So I have negative 2x plus 210 is equal to 180. Subtract 210 on both sides. Negative 2x is equal to negative 30. Divide by negative 2, x equals 15. And we want the measure of the other angle. So if x is 15, how would I find the supplement? How would I find the supplement? Yeah, I could plug it back in, but I also could just do 180 minus 15, which is 165 for the other angle. Okay. It's not so easy.
That's scary.
Yeah. All right. So perpendicular lines. Perpendicular lines intersect to form 4 right angles. So not only are these 2 lines that are intersecting, remember how we like karate chopped each other, like sword fighting, but they specifically all meet at 90 degrees. So all 4 of these would be congruent because they are all 90 degrees. Perpendicular lines intersect to form congruent adjacent angles. So congruent means same, equal, and adjacent are the angles that are right next to each other. Segments and rays can be perpendicular to lines or other line segments and rays. So this is the most important part I want you to see. It's like it's an upside down T. That means perpendicular. So if I say line AD is perpendicular to CB, what that means is I take line AD and it's going to be at a 90 degree angle from C to B. They form a 90 degree. They form a right angle. All right, so let's find X and Y so that BE and AD are perpendicular. Okay, so I have these 2 lines. So I want B to E and I want A to D to be perpendicular. So I need to find what the values of X and Y are. Okay, so who did I leave off on? Jacob, which one do you want to solve for? Do you want to solve for X or Y? Just pick one, doesn't matter. All right, X. So I'm focusing on this angle and this angle. So I want these to be perpendicular, so that means that these 2 angles have to add to 90. Okay, so I know 9x plus 3x have to be 90. Do you want to lead me through the rest of the problem?
Sure. So then we add those 2 X's together.
I think it's 6x.
Oh, you're right. Oops, I'm sorry. I was giving you the answer. Yes, lead me through. Divide by 9. So I see X should be 10. Awesome. Dylan, do you want to help me find out what Y should equal?
Yeah.
So I'm looking at this angle right here, because when it says, so right here, what this is saying is the measure of this angle. So it's listing it out for you.
So it's gonna be 12y minus 10 equals
Yeah, equals 90 degrees. Because this is the only thing. It's only the one angle. It's from AFE, so
which angle is it?
the one tracing out right here.
Oh, which?
So this is AFE. This is the angle AFE.
No, I mean like.
It's complementary. Well, it's not complementary. It's a right angle. We want it to be a 90 degree. So right here, it's talking about how we want these two lines to be perpendicular, the one in example 4. So in order to be perpendicular, these have to meet at 90 degree angles. They have to meet at right angles. Okay, so let's just go through, just, you know, add 10. Divide by 12. So y is equal to, let's see, can we simplify? Can we simplify this at all? Maybe divide by 4. 25 over 3.
Yep.
Okay. I think we're close to being done, maybe. Alright, so 25 over 3. Let's keep going. Uh-oh. Did I just hit this wrong? No.
Come back. Yes.
Okay, I just can't, like, touch it. Okay, interpreting diagrams. Yeah, so we're almost done. As soon as we finish 1.5, we'll take a break. This last page. Interpreting diagrams. So some things can be assumed, some things cannot. So all the points, when you're seeing a diagram like this, you can assume all the points are on the same plane. They're all coplanar, literally on the same plane. H, G, and J are collinear. So these guys are a straight line.
You can't assume that.
Well, it can be assumed.
There might be more than one meaning.
They would have to, like, make it clear. So I'm telling you, when you're looking at diagrams, these are the only things you can assume. They'd have to make it clear that it's not a straight line. It'd be a pain in the butt to have to be like, this is a straight line every single time. All right, so we checked off those. HM, just this guy. HL here, and HK, and G to J, so this line right here. They all intersect at H. So it's kind of clear they all are sharing this one common point. H is between G and J, so we see how it's on the line between them. J is in, let's see, L is in the interior, so L is in the interior of MHK. So if this is the angle, remember interior is on the inside, so L is on the inside of it. GHM and MHL. So these two are adjacent angles. We can also assume, oh my gosh, we can also assume that this guy right here, as well as, pick another color, this one right here, we can assume that those two are linear pairs because they're going to add to 180. And then we can also assume JHK, and KHG are supplementary. Okay. So we can also assume that this angle right here and this angle right here are going to be supplementary because they're going to add to 180. We can also say they are linear pair. Okay. What we can assume that any of them are perpendicular to each other, because in order to be perpendicular, you have to have that 90-degree angle. So HM is not perpendicular to HL. So kind of like maybe, right? This may, like maybe this is 90, but we don't know. So we can't assume that. We can't assume that this angle and this one are the same. Like we don't know. Unless I gave you the angles, we wouldn't know if they're congruent or not. Same way with like this angle and this one. So, Okay. And we can't assume that these segments, like the length here, I can't assume it's the same as this guy. I can't assume that this length and this length are the same. So it's just a good exercise to go through. Whew. Okay, so example 5, determine whether each statement can be assumed from the figure, and then we'll explain. So can angle KHJ, so KHJ, this guy right here. Can I assume that the angle in green and then GHM, can I assume that these two are complementary?
No.
Why?
Complementary. Oh wait, equal to 90?
So complementary equals 90 degrees. But so what do we notice about this line right here and this line right here? Do you see the pink I'm highlighting? So although the angles are congruent, it doesn't mean that it adds to 90. So congruent angles.
You have no idea what KHL is.
Can you read this?
Yeah.
All right, so no, congruent angles don't imply complementary. So although these two angles are the same measure because it marked it for us, it told us this, it was a given, we can't be like, oh yeah, those add to 90. No, we don't know. We don't know. They didn't tell us anything. What about, are we ready to go to the next one?
Mm-hmm.
Okay, so I'll erase my little colors. I feel like it helps you visually. So let's do GHK. GHK is this guy. GHK. And then I have JHK. JHK, so that one. Are these a linear pair? Are these a linear pair? Linear pair means they're a pair of it's two adjacent angles that add to 180. Are
Yes.
these adjacent angles?
Yes.
Yes. Did they add to 180?
Yes.
Yes. Because one of the things we can assume from above, we can assume that this GHJ, right? G to J, this line, we can assume it's 180 degrees. Okay, so yeah. Yes. H to G, so this ray, and H to J are opposite rays. And remember, two opposite rays is 180 degrees. And a linear pair adds to 180 degrees. They're adjacent angles that add to 180. So linear pair, adjacent angles, ones that are right next to each other, add to 180. Since I have this ray, and then I have the ray, and they share the same endpoint, and they're going opposite directions, it's a line, I can assume it'll add to 180. All right, and last one. H to L is perpendicular to HM. Okay. Let's erase this. Let's see what's going on here. Oh my gosh. Why is this freaking out on me? Okay. All right, so HL, which is this, can I assume it's perpendicular to HM? HM. Okay. Is it perpendicular? How do we know? Do we know? So right here,
Oh.
what do we notice that's between these two?
Yes. Yeah, right.
What does this little box mean? 90. And if I want to know something's perpendicular, they have to be meeting at 90-degree angle.
Yeah.
Yeah.
Because,
So,
yeah,
I can assume these two are perpendicular because
oh my God.
they have the right angle symbol. So right angle means 90 degrees.
Oh, that was so weird.
They have the right angle symbol. So whenever you have two rays who share a common vertex, it's an angle, and if that angle has a little box, that means they meet at 90 degrees and they're perpendicular. Awesome. Okay, so I'll pause the screencast here. 4.6 is two-dimensional figures. So a polygon, so wait, let's break this down. What does poly mean? When have you heard of the word poly before? Huh? Yeah, poly means multiple. So I'm trying to think of a good example besides going straight to Utah. Like polygamy, having more than one wife, versus monogamy, mono is one. If I'm trying to think of more examples that are not morbid, especially because I'm screencasting it for Kaylin. I don't want her to like die in shame. Let's see, poly just means more than one. So a polygon has like multiple sides. So a polygon's a closed figure formed by a finite number of coplanar segments called sides. Pause. What? Finite means there's just a certain number. It doesn't go on forever. Finite, you can count it. Number of coplanar segments. So coplanar, all of the segments are on the same plane. They're not being skewed and like random. It's kind of like if you have a bunch of hay or sticks and you like pour them. You know, they're like pointing everywhere. Nope, all of these sides are on the same plane. The sides have a common endpoint. The sides that have a common endpoint are non-collinear, meaning they don't form 180-degree sides. Each side intersects exactly two other sides, so it's not super crazy. And the vertex of each angle is a vertex of the polygon. A polygon is named by the letters of its vertices, and they're written in order of consecutive vertices. So if you start going around naming them, you just gotta like keep going all the way around. Okay, so notice that if I start at side GH, I gotta keep going. GHJKLM. It's a pain. It's a long polygon. Anyway, so let's decide polygon versus non. So let's decide, why is this guy not a polygon? Why is this not a polygon? Can we decide from one of the definitions? Why is it not a polygon?
Because it intersects.
Exactly, because it intersects and they're not supposed to. So if you look at the reasons, things, how do you know if something's a polygon? They have an endpoint, they're non-collinear, they intersect exactly two sides, but only at the endpoints. This guy intersects in the middle, so that's not an endpoint, that's why it's not a polygon. What about this guy right here? Why is that one not a polygon?
It's not attached.
Right, it has to be a closed figure, and this is an open figure. Oh my gosh, who made this? Okay, next. What about this guy right here? So it has to be segments, and these are curves. So that's a no-go. And what about this guy right here? Why is that not a polygon? The vertex of each angle is the vertex of a polygon. Like, it's all of the sides connect to two others. So if you notice, like, this guy right up here, if I could just cut that chunk off, I would have a polygon. But it's sticking out. That's not good. Here, this is a curve. These are curves. It's got to be sides. We got to have segments. All right. Convex versus concave. So before I show you that, well, it's on your paper. Never mind. Where have you heard the word convex, concave before? Maybe like the eye doctor's office. So if you have glasses, you'll notice that there's curves to them. If you know those like popper things you get, they're really cheap, and you like flip them inside out and you put in, they like pop up. Okay, that's a good example of convex versus concave. So if it is like caving in versus like if it's like popping out versus caving in. So here when I talk about convex versus concave, I'm talking about the angles, the line segments. This is going to die on
What do you
me.
mean by that triangle? Oh yeah, it's a polygon because there's multiple sides.
Yes, there's multiple sides.
So concave means that it goes in, and convex means that it doesn't.
So a convex polygon means technically all the angles are less than 180.
Oh right.
All of the angles. Versus a concave has an angle that's over 180. So if I look at this angle measurement right here, that's over 180.
But then you can divide that
So-
up into two convex.
So like this, I could have two different convex triangles inside if I would divide it up by that and that. Anyway, so convex versus concave, how's your book describe it? Convex polygon, no points of the lines are in the interior. So the interior is on the inside. So imagine if I would just take every side and make it be a line instead of a segment. If the lines if part of the line like overlaps inside the polygon, then it's gonna be concave. So what it means by that is like, guess what? This will only happen if you have an angle that's over 180. There you go. Just told you the hint. You're welcome. All right. How do we name them? So 3-side is a triangle. Tri is 3. Triangle, a tricycle has 3 wheels. So the prefix tri is 3. Angle, of course, is angles. Literally 3 angles. Triangle. Quadrilateral, quadriceps. What's another example? Like the quad is 4, a quarter. So QUA, it's like 4. Quadrilateral has 4 sides. Pent, like the pentagon. What else? What's another word with pent? Do we know? Yep, penthouse, but that doesn't really mean 5. So pent is 5, hex is 6, hept 7, oct, like an octopus, oct is 8, nonagon 9, decagon, like a decade, a decimal.
Memorize all these?
These are the ones you should know.
Oh no.
And if it's over 12, you just say whatever it is, gone. So like for example, a 20 would be a 20 gone. Because yeah, they don't pop up in your life very often. Versus, I see an octagon every day on my way to school. There's a stop sign. I see quadrilaterals all around me. I see them everywhere. Look at your tables. Look at your books. Ugh. All right. Let's keep going. So more vocab. Equilateral polygon. Equal, right? So congruent. Lateral is like a side. So equilaterals, all the sides are congruent. So kind of like the lateral face. What's a good way to think of? If you have a lateral movement, I don't know if you play sports, lateral movement side to side. So equal lateral, equal sides. So another example is if I would have a triangle, what do we call this? This is a equilateral triangle because all of the sides are the same.
Huh. Yes.
Okay, without looking at the definition, what do you think equal angular means?
Equal.
All the angles are equal. Equiangular, equal angles. All angles are congruent.
Oh no, it doesn't mean that they have to be 90 because then it could be a...
Well, right. So if I would go up to this triangle, guess what? All of these angles would be the same in my triangle. If I would have, maybe, let's see if I can draw it. A regular pentagon. Oh, it's kind of close. If you like squint or just plain up close your eyes, it'll be the same. So all of these angles would be the same.
If the sides are the same, the angles are the same.
So a regular polygon, so I drew, so let's see, this is a quadrilateral right here. This is a triangle. This is a specific, this is a rectangle, I think you know about that, but then this is a pentagon. Okay, so a regular polygon is a convex polygon, meaning if I would extend each side out and make it a line, right, if I extend each side out, make it a line, do the lines like go through the shape? No, they don't hit any of the interior. Okay, a regular polygon, it's convex. It is both equilateral and equal angular. All the sides are the same length, all the angles are the same measure. Equilateral, they all have the same length. So notice they're all 4 inches here in my example. Equal angular, they're all the same angle. Every single one was 90 degrees. So same side, same angle. Okay. Questions so far? I'm trying to do a better job of not just blowing past you. Cool. Okay. And like if I like make eye contact with you, you can just be like, no, and I'll slow down. Whatever. Yeah. All right. Name each polygon by its number of sides. Then classify it as convex or concave and regular or irregular. Okay. So remember, regular means same sides. They all have the same side. They all have the same angles. Okay, so let's see. If I look at number 1, how can I label it by a number of sides? How many sides does it have?
Definitely.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. So it's a decagon. Okay. And I have what?
Can we take this to the test?
No.
The thing with all the sides and the numbers.
Nah. Is this concave or convex?
Concave.
Okay, because imagine concave is like if I would extend each segment into its line, into a line. Do any of the lines go inside the shape?
Yes.
Yeah, so check out right here. Right here, it's on the interior. So it's not a normal, it's not a normal convex, it's gonna be concave. And remember the way I remember that is like, imagine you're going inside a cave. Like you're going inside the cave of your shape. Okay, I don't know. It doesn't work for everyone. You can think of your own way of remembering it. Concave. So if it's like caving in, haha, it's inside caving in. Okay. And is it regular or irregular? So all of the sides are the same, right? So regular means equal lateral. All the sides have the same length. Equal angular, they all have the same angle. So I notice that every single side is the same length. Okay, halfway there. What about the angles? So here's one angle. What about this angle right here?
Over 180.
Ooh, so are all the angles the same?
No.
This angle is not the same as this, so it's an irregular. Because not every single angle is the same. Okay, so I have two specific angles. It's either going to be the acute, less than 90, or the obtuse, over 90 angles. Here it's over 180. There's only two angle measurements, but it all has to be one. They all have to be equal angle. All right, let's go to B. Who did I leave off on? Dylan, did you do a problem?
I did it.
Oh yeah, Edwin. Okay, Chauvel, you're up. So I want you to lead us through how, let's name this polygon. Yep, so 6 sides, so it's a hexagon. All right, is it concave or convex? How do you know? Yeah, all the angles are less than 180. Perfect. And then is it a regular or irregular? How do you know? Exactly. Every side is the same. Check those out. Every side is the same. And all of my angles are the same. And that's how I know it's a regular. Okay, so perimeter, circumference, and area. So I have it, P is perimeter, A is area, so that helps you out with that. So if I want the perimeter of the triangle, I just add the 3 sides together. The perimeter is like your perimeter, your yard. You're wanting to build a fence. However long your fence is the perimeter of your yard. It's the outside part. If I don't know the area, right, so imagine being David Marcus, he has to figure out how much sod should we put in. We got to find the area of the horseshoe. But before he can do that, he had to find the perimeter and figure out how much caution tape he had to put around it. Real life example, there you go. All right, so the area is 1/2 base times your height. Notice it's not one of the side lengths, it's literally how tall the triangle is. A square, the perimeter, you just add, once again, just add all of the outside part together. And then if you want to find the area, base times height again. But it turns out the base is just the same length as the side, so it's just going to be the side squared. Rectangle, length plus width plus length plus width. That is the perimeter. Area, you're just doing base times height, so length times width. Circle is 2 pi r or pi d. R is the radius of the circle. It's the distance from the outside to the exact center. That's the radius. Diameter is twice the radius. So 2 times your radius is the same thing as diameter. That's why these are equivalent. And the area is just pi times your radius squared.
I have a question.
Yes.
Why, if it's 2 times pi times radius,
Yep.
why don't you just do pi times
Diameter?
diameter?
Either one's fine. But if I give you radius, you might as well just plug it in instead of having to find diameter and then plug in.
Got it.
Depends what I give you. Okay, So let's go ahead and let's find the perimeter or circumference and area of each figure. Okay, so perimeter and area. Here, what kind of shape do I have, Maya? Triangle. Okay, and so I need to find the perimeter, I need to find the height. Which would you like to find first? Oh my god, he's so loud. Okay, how do I find the, let's do area first, that's easier. How do I find the area? So for a triangle, it's 1/2 base times height. So 1/2 of 6 times 8. So here, area of a triangle. 1/2 base times height. So here that's 1/2, 6 times 8. Half of 6 is 3. 3 times 8 is 24. And what's the units? Feet squared, because it's an area, it's squared, feet squared. Okay, perimeter, it's a little harder. It's a little harder. How could I find the perimeter, Maya? I have to do what? I have to add up all the sides, but I don't know what this side length is right here. Ugh, how do I find it? A cheval. So she said, hey, guess what? I see this is a 90-degree angle, which means it's a right triangle. We can use Pythagorean theorem whenever I have a triangle that has a 90-degree in it. So she said Pythagorean theorem, a squared plus b squared equals c squared. So I have 6 squared plus 8 squared is going to be whatever this longest side of my triangle called the hypotenuse, that will be whatever it is, squared. 36 plus 64 is c squared, so 100 is what my hypotenuse squared is. So if I square root both sides, 10 is my last side. Perfect. And then she said we just add up all 3 sides. So the perimeter in a triangle, here you just add up all the sides together. 6 plus 8 is 14. 14 plus 10 is 24. Weird that it's the same actual number, but they mean different things. So here, perimeter is just a length. It's like how long should the fence be? Oh, 24 feet of fence should be able to box this in. Do you have any questions? Cool. All right, let's go to the next one. I think I'm back to Ashton. All right, perimeter and area.
All right, so the perimeter of this should be pi times the diameter.
Cool, so how do you know that this was the diameter?
I know that that's the diameter because it shows the line going through it and the 6.2 above it.
Yep, so it's going from side to side. It's not just from the middle out. Okay, so if I do pi times d, we can use pi is about, let's see, okay, so I could just put like 6.2 pi centimeters. This would be exact, but if you plug it in your calculator you can get approximate, so that'd be 19.5 centimeters, so that's approximate. What was that?
I don't get it.
So if I leave it 6.2 pi centimeters, that's exact. So if I say
Got it.
I want exact answers, you would leave it in terms of pi. If I said approximately how much is it, you could use decimals.
Okay.
Just trying to be clear with my wording.
What
Okay.
pi was like 13.4?
3.1415.
3.14. And we
Yeah.
have to memorize that.
I mean, it's on your calculator, but you should know pi.
Right.
Okay, and then the area for circle, Ashton, do you want to finish this out?
The area will be 6.2 squared times pi.
What's the equation again? Pi r squared? We have the diameter, not radius. How do you find?
Oh, right. So you divide 6.2 in half and you get 3.1, and then you do 3.1 squared, and then you get 9.61, and you do 9.61 times pi, or to get an estimate, equal 9.61 times 3.14, and you get 30.1754.
Cool. So like 30.2. So if I wanted exact, I would have you write 9.61 pi centimeters squared. And the reason we leave things in exact form is because later, if you take pre-calculus or any math after that, trig and advanced algebra, you will have to know how to leave things in pi. Right? For trigonometry, you have to leave things in pi. Because pi is actually super useful. So a lot of times people take geometry and think it has nothing to do with other classes. 100% geometry is used everywhere secretly. Just behind the scenes, pulling all the weight. All right, example 3 is the last one, then we'll take a little break and do some homework. How am I doing? Aha, really close on time, awesome. Find the perimeter or circumference of each figure described. All right, so I want the length of a rectangle. The length of a rectangle is twice the width. Okay, so if I draw the triangle, I'm sorry, what did I say? Rectangle, twice the width. Okay, so here's my width, and this is my length. My length is twice the width. So this is a script L. Oh my god. This is a script L. And it's 2 times the width. The area is 50 square meters. So I know the area is 50 meters squared. I also know the area is literally length times width. If you look at the top of your paper, it says A equals LW. But I know that the length itself is 2 times the width. So another way to write this is the area of this specific rectangle is going to be 2w squared. Because this specifically said the length is twice the width, I rewrote length as 2 times width. I'll pause here. Let me know. Are we grooving or not? Okay? Okay,
Yeah.
so we see where we're going. We see where we're going with this. So I'm going to write the area, which was 50 meters squared, is going to be equal to 2 times the width squared. I got to finish this out. I got to solve for what my width is, right? Because I want the perimeter, so I'm going to have to go back, solve for width, solve for length, and then find perimeter. Okay. I wrote really big. I have to divide by 2 on both sides, so I have 25 meters squared equals the width squared. Square root both sides, I have 5 meters is the width. Okay, go back. I'll scroll a little bit. So this is 5 meters. The length is 2 times the width, so that means it's 10 meters. I have the area. I need the perimeter. How do I find the perimeter? Who am I on? Aha. Noah.
Oh, perimeter, so you add the length, so 10 plus 5.
Plus 10 plus 5?
Yeah.
So I have to add 10 plus 5 plus 10 plus 5. Or I could do 2 times 10 plus 2 times 5. So up here, it like simplified it. Instead of having, if I add L plus L, it's 2L. If I add W plus W, it's 2W. So 2 times length plus 2 times width. So 2 times 10 plus 2 times 5, so it's going to be 30 meters is the perimeter. Yes.
So in this, you did the, oh wait, it's inside the parentheses. That makes sense. Because you did the division before you did the square rooting. And then,
Yeah, divide by 2, yeah.
And then I just realized that's because of the division within the parentheses. Right?
I'm not sure where you're
'Cause
looking.
you
Parentheses.
see how it's like 2W
2W times W?
squared,
Yeah,
and
2W squared, yeah.
Yeah, so instead
So this is
you-
2 times W squared. Since I was
Give it
multiplying by 2, I can
first.
divide by 2. Yep.
Okay. I'm
Awesome.
questioning my PEMDAS.
You are or not?
Yep, I am.
Because you have to go backwards through. So whenever you're like solving, okay, if anything's being added or subtracted a thing, get rid of that. Then you can deal with anything that's being multiplied or divided. Then you can deal with the exponent.
Oh my god, right.
Okay, it's chilling. I'm glad it's today and not like in
Yep.
2 weeks.
Yep.
All right, so the area of a circle is 64 pi square inches. Okay, so the area is 64 pi inches squared. And I know area of a circle is pi r squared. So what I would like to do, I'm going to set these equal. So I have 64 pi is equal to pi r squared. I would like to know what the radius is because I have to figure out what the perimeter is. Perimeter is 2 pi r, so if I can find my radius using the area, I can plug in and find my perimeter. So it's kind of it's probably a little overwhelming. I know the area, I can work backwards. Instead of plugging in radius to find area, I will solve for radius I will plug in area and solve for radius. So divide by pi on both sides. So 64 equals r squared. Square root both sides, 8 inches is the radius. So now if I plug that in over here, the perimeter is going to be 16 pi inches. 2 times pi times 8 is 16 pi inches. Awesome. Okay, so I'll pause here.